interdependent. This is a very strong message that biodiversity should also call. Meaning that we have more and more information from the ecological sciences, and the message is very clear. Everything is interconnected, and the link between soil, plant, animal, and human microbiome is calling more and more the attention of the scientific community, and also involving, I mean, the medical doctors, ecologists, engineers, and we are all, I mean, the idea that what the quality and the health of the soil is also the health of the animals, the plants, and our health is more and more clear. So what the soil microbiome clearly influence one health and our health. So this is just an overview and just a review and a paper that I think is very interesting if anyone wants to go deeply into this topic. So that's, I mean, this is one of the reasons that more and more will demand for a change of the agricultural system, meaning that we want and we should go for the regeneration of agriculture, and the meaning that one of the most important components of this process is the restoration of soil health and the reversal of biodiversity loss. So that's the way how we've been producing, and in general also, I mean, different aspects, and we are just, I mean, starting today with one that is probably the most important, that is the seed. The seed is the embryo of the plant, so we should, that's the baby, that's where we should put a lot of efforts, because it's the beginning of the life cycle of an organism that is an essential part of the life system. So, I mean, so now we've been focusing a lot in the organic, so the least harmful inputs, and organic is a concept that is already something, I mean, meaning a change in the process of producing food, meaning, I mean, that we want to remove from the system, I mean, some of the impacts, but I mean, the transition for regenerative agriculture means that we want to work with nature, and nature is working with us for this transformation of the system, and it is huge. It is a huge demand, but it's amazing, because at the same time, this is a process that is also impacting in the way of we've been also communicating as societies, and that's, I think, and I strongly believe that is, in many ways, this is a peaceful agenda, because it's we are providing all the knowledge that we have to transform the way we connect to the land, to nature. So that's, I'm a strong supporter of agroecology, which is a holistic and integrated approach that simultaneously applies ecological and social concepts and principles to the design of management of sustainable agriculture and food systems. The whole idea is to optimize interactions between plants, animals, humans, and the environment, while addressing the need for socially equitable food systems within which people can exercise choice over what they eat and how and where it is produced. So it's a set of practices in the social movement, but it's a full transformation of this connection between societies, human societies, and land. So where do we have, when we are discussing the seed and the seed coating? That's what I would like to bring part of, and I have other colleagues presenting other solutions. One of the solutions that agriculture is developing is exactly working with the seeds and using what nature already give us as a solution, that is the role and that the beneficial soil microorganisms can play and help us to support, let's say, and to enhance the capacity of the seed and the full system. We have, in terms of regenerative systems and the seeds as the foundation of regenerative systems, I'm just bringing a couple of ideas that are important for this transformation. One is certainly biodiversity and resilience, meaning that diversity and locally adapted seeds contribute to ecosystem resilience against pests, diseases, and climate variability. All farmers know this, and that's one of the reasons why we were for centuries we were very much focused in preserving seeds, have a seed bank, have a legacy, and these cultural seeds were always connected to some sort of biocultural heritage because the farmers understood always the need to preserve the seed and the quality of the seed in terms of biodiversity. And then it's seed sovereignty, empowering farmers to select, save, and exchange seeds, supports autonomy and strengthens community knowledge systems. Again, that's bringing the biocultural heritage and trust that we have a lot of knowledge that is not yet part of the system, and this is a loss. It's a loss of biodiversity and a loss of knowledge. Then the climate adapted and stress tolerant varieties. So we will go for the development of drought, heat, salinity, and flood tolerant seeds to ensure productivity under changing conditions. It is very important under climate change, scientific advances. In my, very short talk, I'm focusing the seed as a careers of microbial allies. So we do have in the system microorganisms that are beneficial, and we can use them in order to improve the quality and the strength of the seed. And so seeds can be coated or pelleted with beneficial microbes as mycorrhiza, nitrogen fixers, phosphorus solubilizers that enhance nutrient uptake, reduce input dependency, and improve soil health. And seed microbes act as a biological gateway to soil regeneration. And that's one of the challenges. And I would say if we prepare the seed using beneficial microbes, I believe that this can be a very interesting and very knowledgeable process. It's of change. So we can use arbuscle mycorrhizal in particular, or plant growth promoting bacteria, and that's the two kind of microorganisms that we tend to know better, and we are more and more using as part of the seed coating process. So the broadcasting, and we all realize the role of these organisms in many ways in the physiology and the biogeochemical cycles. We cannot broadcast of inoculum in open agricultural fields. It is not economically viable. Non-target spreading of inoculum over large areas results in high cost per plant and per area. No feasible technologies for application of AMF inoculum in open field agriculture. So the seed coating technique is rather simple. That's again one of the advantages, even though it can take simple. It may look simple, but it can be experimentally challenging. But it's a technique in which finely ground solids or liquids are they're around the seed with a coating material. This is a very simple process. Looks like a simple process. It takes some time, but there are some references that you can use in order to understand the process of inoculation. In this case, from PGBP, the bacteria, and the mycorrhizal. So the seed coating is a process to reduce the amount of inoculum needed for an effective inoculation. Then you have to process and assess the inoculation, making possible the application of beneficial soil microorganisms in open field agriculture, reduction of fertilizers, so reduce the dependence of chemical fertilizers using AMF and PGB, and increase the plant resistance of legumes to drought stress. We have a number of ongoing projects that show this. I don't have time to show the outcome, but because the meaning of this talk was to show, to integrate. We have a number of, so that's just a short image of what looks like one species that was, that seed coated. It was coated, and now and the same, but they are coated with microorganisms, in this case, mycorrhizal. So it's another example, and I could jump to another, but I don't think it's useful. We are, as I said before, we are applying this seed coating process all across Europe in 14 different living labs. It's the GOOD project, and this project is, the idea now is specifically to address the problem of preventing the expansion of weeds in farming systems. So we are using seed coating to prevent weeds in our organic and conventional farming systems. The project is called GOOD. If you want to have it's Good Agroecology for Weeds.
Thank you. Thank you very much, Helena. That was a very nice presentation, very insightful. I think you spoke nicely about the One Health approach, right? And then you talked about agroecology. How do we look at it from the holistic and integrated approach? You also talked about seeds as the foundation of regenerative systems. And finally, you brought us, the audience, to seeds as the microbial allies to carry all kinds of substances like the arbusculus. I think that was very well received. Let us see if there are some questions for you. Yes, there is one. I'm sure people are typing and it's coming in. From long-term seed storage perspective, how helpful will it be for seed coating? Right? Will there be any ill effects on seed viability during storage if they are coated?
That's an amazing question, and I thank you very much for the question, because it's really a good one. We have been essentially working with the seeds that we have available in order to apply in the farming systems, but we don't have much knowledge in terms of long-term, a collection of seeds. That's an amazing question, because it's a long way to go, certainly. I mean, I don't have really, honestly, scientific information regarding this aspect, but I think that is extremely important and could be certainly a topic of scientific exploration that we don't proceed at this point. We are essentially trying to, because this is, I mean, the process itself can take some time, and basically we are trying to apply it for specific conditions, because we want to prove that is really making a change in the either preventing the use of fertilizers or the chemicals, or preventing weeds, or giving, new inputs into the system. So this specific question, I don't think that has been really addressed in terms of science, and I think it's a very important and critical aspect. Thank you very much. It's an open way to go, certainly. Thank you.
Right. Obviously, more research and development is needed in this direction. Yeah. Okay, there's another question. I think it's highly related to the first one regarding this shelf life of the microbiome after coating. Have you considered this and checked this aspect?
Yeah. This is, it's actually part of this ongoing project that I was calling your attention. Is we are actually doing the genotyping of the outcome of the results of the living labs, and this is part of the process of our intention and the results. Yes. All the assessment, the full assessment of the result of the application of the seed coating, in terms of the full spectrum of microbes that you can get. So this is going to be part, certainly, yes.
Okay. Well, there's another question. How long does seed coating process help in biotic and abiotic stress mechanism?
I'm not sure if I could you repeat, please? I couldn't follow.
How long the seed coating process help in biotic and abiotic stress mechanism? I believe they are talking about effectiveness after you plant the seed coated. Yeah. How long does the effect last?
Okay, well, we tend to assess it whenever we apply, and the outcome is the time itself. The production itself. It's in the farming system. So if we introduce a seed coating in the system, we tend to wait for the accomplishment of the life cycle of this specific farm system, and then we assess the outcome, and we have the results immediately afterwards. So we tend to assess the impact of the seed coating in the end of this production year. So, and that's the kind of results we have. It's a kind of it's yearly based, and it's farm based, let's say.
Okay. Another one. Does seed coating have any long-term environmental impacts, particularly regarding the use of synthetic materials or microplastics?
Well, we are not using them. So, but probably I would say that there are certainly, companies and industries. I'm just, a researcher. We are producing knowledge in order to, support the even companies that I know that are producing new technologies and are using it. They are developing technology in that sense. Might be, but in our case, we are not using any kind of artificial elements. It's just, microorganisms from the locals. So we are, the process, I didn't explain it entirely, but if we, in our case, we are using inoculum from the field, from the farm system, and we are using it in the seed coating process. So we are basically working with the microorganisms that are in this specific farming system. So we are not using anything from abroad, and we are not using, an industrial process. So we are not using any artificial element. It's not. I don't think that we are, introducing anything that is not in the system. The microorganisms are from the system.
Okay. I think this probably relates to the process actually. And
Yes.
there's a general understanding that the polymers used for coating, there's a
Yeah.
huge shift
Okay.
from
That's
the
another question.
chemical to
Okay.
bio actually.
Okay.
Yeah.
Okay.
Yeah. Okay. Okay. Another question. Regulations are becoming equally stringent for biologicals as that of other chemicals. How do you
Yes.
see the impact on ease of using them?
Yeah, that's another. This is also an important question, and as a biodiversity defender, of course, this is a risk. And in our situation, that's the one that I was presented. We tend to use, as I said, the biological material that is from the field side. So we are not introducing anything new, but it's true that we are also using, some, let's say, test organisms that can be an exchange. It can represent an exchange of biological material or genetic material, and this is important. And I would say that it's a risk, and we should have regulation, yes, to prevent. But that's always a challenge. How much risk can we apply in order to come up with solutions that are really useful, for the change of the whole system? I would say that we should have at least to target a few organisms that are already part of that. We have more and more organisms that are eventually much more much more common and worldwide expressed than others. Then maybe we should tend to use them, and because we have more knowledge in these organisms as tests than simply using whatever because then the risk is increasing. If you use new organisms in the system, then the risk is increasing. So yeah, I think that in this area we do need some regulations that are not yet probably available, and we should work on them. Yes, and these kind of associations, as the one that you have, are exactly the ones that can help us. And thank you for these kind of workshops, or where we should share our concerns, and in a way that's the way to go, because it's public, it's open, we are discussing the topics, and that's where we come up with the best solutions that are really for all of us. So that's
Thank you. There's one more question. I think this is a general question. Which type of seed do you think is more suitable for regenerative agriculture, local or hybrid?
Yeah. I tend to select species that are in our, which we, biodiversity is our best ally, always. So I tend to preserve biodiversity, local biodiversity, and whatever we have, and we should keep it as much as possible. And I'm, as an ecologist, I'm in favor of also some population diversity if you can. So I tend to favor local species and the use of local species as much as possible. But of course, sometimes we may face difficulties in that sense. We don't have enough. We don't have available. So and we have to produce food. So I understand, but I will go for local diversity and native species as much as possible.
Home is always the best, isn't it?
Yeah.
Okay, one more question here. Introducing foreign microbes to Malaysia. This question is from the audience in Malaysia. Introducing foreign microbes to Malaysia, especially for bacterial-based disease control. Do you have any insight on insight to approach for local conditions?
Recording in progress.
And it may also make me think, because I'm not an expert in all the topics, but I think that Malaysia, is a huge country with a lot of diversity. It's probably one of the most diverse countries in the world. Certainly, whenever you have plant diversity, you have microbial diversity. I don't think there's a need to import microbes in any sense. I'm sure that you have enough microbial diversity in your soils, in your plants, in your systems to use and apply in this regenerative transformation. Actually, the regenerative agriculture, the part of the process of understanding and change is also, keeping the biodiversity, the native diversity, and not only plants and animals, but also microbial organisms. So I don't see the need. But eventually there are, of course, that's typical, and we'll have more and more microbes and the microbial technologies available, and then they may support, but we have to be careful and assess if there's a need for some of these applications of foreign microorganisms in our native systems, because I'm sure that you have enough variety, enough diversity in your systems to work with. It's probably the first investment I would say would be to work with the native species and develop them, understand the role they may play in your native systems, and then eventually work with others. I don't think that you need. Malaysia is an amazing country full of ecosystems of high quality, and we are lucky. You are lucky to have such a high quality of ecosystems.
Thank you so much. Helena, do you want to comment a little bit on cost? When we talk about non versus coated, how would you look at this aspect?
Yeah, I think at the moment probably this can be more. This is certainly an important aspect, but I would say that is. The process itself of seed coating, the kind of the way I've showing it, is not. It's costly, but it's not. In terms, it's not a high tech kind of cost exercise. What is the cost is the time you need to work the process, to perform the experiments. That's probably. But I don't think that it's in terms of if this is a way to go, and if you choose this as a process, and I'm sure that this will become more and more useful and applied, and all across these new ecosystems or new farming systems that we want to transform. I think this is going to be more and more a practice. And I don't think that is extremely costly if you compare to other solutions. I don't think this is a solution of high cost. I don't think so.
Okay. I've got one very interesting question for you. In a country like India, where you have huge climatic variation, will it be a good idea to use multiple organisms for seed coating?
Yeah, that's a good question. Yeah, again, India is the country where I can see from what I read, and I've had the chance and the luck. I was lucky enough to visit. There's a lot of transformation ongoing in farming systems, and there's a lot of knowledge in related to these regenerative systems and in agriculture. So, in fact, you have drought problems in many parts of the country. And I'm sure this probably one of the regions where I think this process can be most useful. Exactly, the seed coating and the use of microorganisms, in particular, the use of microorganisms, is going to be more and more applied in order to cope with climate change situations. So I would be in favor of that. Yeah.
I do not see any more questions in the chat box. Maybe some are still typing, but I'll just take or allow one question more. Okay, one came in. Do you think it will be ideal if microbiome combined with microplastic-free polymers? I think the answer is a bit obvious, but please.
No, I don't, I'm not sure what you would like. The question is, well, microplastics are in all our food research center where we have a group of people working in marine systems and terrestrial systems with exactly, and showing that we have nowadays plastics are crossing all the borders of our life systems, which is really a critical aspect in the risk. But I don't think that this seed coating is part of this noxious process of invasion of plastics. I don't think so. This can be totally, plastic free. The application of because this is is nature supporting us, because this is happening in nature. The connection between plants and microbes is the very basics of occupation of land by plants. It's going on for more than 400 million years. What we should learn from nature, because there are a lot of solutions available if we pay attention, if we learn from nature. And using microbes and beneficial microbes, because for decades over the last 80 years, we have been impacting the farming systems in general exactly by harming being harmful to this collaboration between microbes and plants. And the whole idea is somehow to heal the system, as to help the system to heal by bringing the good microbes that help plants, and the good microbes are to change the entire system and to work for One Health agenda as our inspirational process of change.
Thank you, Helena. I think you used some very nice words, friendship. I think the concept is to enhance and invigorate the already existing friendship.
Yes.
We
Yeah.
kind of undo. There's a comment for you, Dr. Helena. Thank you for the wonderful presentation. But there's also a question. What is the longevity of the coating you discussed?
Well, as I said before, unfortunately, we tend to use it to respond to a near process of production. So we tend to go for the short-term kind of impact and outcome, because we want to produce results faster, and so the process is dedicated. In our case, as researchers, I'm not a company, so my all I mean, this is just we are studying the process itself and the way of bringing more knowledge into the system so that it is going to be applied. So we are focusing the short-term outcome of the process, and whether the question is more into the long term, and I understand, and it's very important, but we don't have yet enough information to provide, and I don't think that we have yet available in the scientific publications, and the long term impact is, in a way, it's astonishing, but it's a rather new process in science. It shouldn't have been, but it is. But you have to think that also, using and applying and working with microbes is something recent in the transformation of the food system. So it's we don't have much information regarding long-term impacts and long-term assessment, unfortunately, but it's important. It's certainly important.
Okay. There's also one last question, but I think it's similar. It's also talking about how do you extend shelf life of microbes, and I think you've addressed that, so we will not repeat. Since there's no other questions, Professor Helena, I would like to take this opportunity to thank you very, very much for that very interesting presentation. We understand you have another event to attend,
Yes.
so please have a good day at the other event. Thank you
Thank
very,
you very much. My pleasure to join you today. Thank you very much. Bye-bye.
Okay, we will now continue our session with the second topic for today. And this presentation is unique because it'll be shared by two presenters, Barry Hoff and Carola Peters. Let me introduce Mr. Barry Hoff first. He is the lead research scientist of Incotech, with a background rooted in agriculture. Growing up in a family of cauliflower families, Barry developed an early interest in understanding the processes behind plant growth. This curiosity led him to pursue a degree in biotechnology, ultimately shaping his career in the seed sector with a strong focus on sustainable food production. In recent years, Barry's work has concentrated on developing seed treatments that help young plants cope with osmotic stress. Through this research, he and his team at Incotech have recognized the significant impact of climate change on agriculture practices. This has prompted a shift towards addressing the increasing challenges of biotic stress in agriculture, with the goal of developing seed treatments to mitigate these stresses. Carola is also a lead application scientist at Incotech, specializing in biologicals. With a degree in biotechnology and over a decade of experience in the application of biologicals on seeds, her work focuses on ensuring the safe application of microorganisms on seeds, as well as subsequent outgrowth of the microorganisms from film coats or pellets. The team at Incotech works with a wide range of microorganisms, each requiring different application techniques. This diversity underscores the importance of tailored approaches in their research, as there is no one size fits all solution when working with microorganisms. So the title of the presentation is Biological Application on Seed for Regenerative Agriculture. And I will allow Barry to start, and you can then pass on to Carola. The floor is yours. Thank you.
Afternoon, good morning, good evening. Like already mentioned, my name is Barry Hoff, and I will be sharing Carola and myself our presentation. If you give me one moment, I think. Here we go. We are going to talk about biological application on seeds for regenerative agriculture. And already mentioned, we'll be giving this presentation together with my colleague Carola. We're both very enthusiastic about giving this presentation, and I hope that through our presentation we can spark some interest in this field of agriculture. This is the exact moment. Yeah, here we go. Yes. First off, we as Incotech are very invested in regenerative agriculture, and there are a couple of reasons why. This presentation that we will give is purely from, or it's mainly out of the focus on the European market, which can also be translated to other global markets. But regarding in the EAME region, why are we focusing more and more on regenerative agriculture? Well, number one, there are a couple of trends going on in our market, and one is that we need to be microplastics free, and all our seed treatments needs to be, so I'm generally talking about pelleting and film coating of seeds. All of those solutions need to be microplastics free and biodegradable. That's not just a trend, that's a requirement nowadays. We are not allowed to put any microplastics into the ground. And everything needs to be biodegradable. So, one of the other trends within the European market is increased focus on moisture management. Agriculture tends to be, needs to be tended to be irrigated via, et cetera. And there's now a shift going on, which we're going more and more towards drip irrigation. Another trend which we are currently focusing on is vertical farming, hydroponic systems. These systems tend to be more productive, less area effective, so of less how do you say it, land intensive, because we are dealing with disappearing agricultural land due to building developments, but also just due to more and more extreme microclimates within Europe, which, like I already mentioned, with vertical farming, 9 out of 10 times we're also talking about hydroponics. So we're talking 10 times we're also talking about hydroponics. So we're talking about the production of mostly leafy and greeny vegetables purely on water. Another trend which is slowly getting traction within the Europe region is the use of polyculture, and that also is a very nice link to the previous presentation. Polyculture, they are advocating that it is less intensive as in the use of actives, of pesticides, as certain plants can function as guarding plants towards other plants within your culture, so to say. So these are all agronomical practices. And why are we doing that? Why are we moving away? Because, like I already mentioned, we in Europe are facing new challenges, which makes so the challenges that we are facing within Europe, like I already mentioned, had to irrigate that well due to a continuous rainfall. People are now using the pumping up of salty water and then dispersing it on top of the fields, which leads to salinization of soils. Now, those are environmental challenges, but also from the European point of view, we are also faced with a couple of legislative challenges. More and more conventional actives are being banned, so fungicides, pesticides, herbicides, more and more they are being banned and they're not being replaced. So that means a new way of farming needs to be established. There is a ever demanding or an ever stricter demand, or there are ever stricter demands for the admittance of fertilizers. So it needs to tick off a couple of boxes before they are being, which makes it difficult on developing products for said biologicals. So, like I mentioned earlier, one of the main challenges within which leads us to focus more on regenerative agriculture is that increase of abiotic stresses, higher temperatures, more moisture, more soil. So that is where our one of our research focuses comes into play. Within EcoTech, we are developing seed treatments which mitigates abiotic stress in young plants. But when we started focusing on our research, we found out that there's very little consensus of what abiotic stress and what abiotic stress reactions are. So we started our research from the ground up. So what are abiotic stress reactions? How can we quantify what we are seeing? For instance, you're seeing here a picture of tomato plants which have been S.E.E.D. with the plants that you're looking at. Well, as you can see, the left one has been exposed to drought, the middle one has been exposed to high levels of salt, and the right, in the graph on your left side, you basically see that in the seedling stage and in the plantling stage, all plants, regardless of their preconditioning or under their growth conditions, there is no measurable reaction within the plant. There is no, we can, from a metabolic point of view, can basically state there's no stress reaction happening. But then if we go at the fourth leaf stage, so the plant has established a fourth true leaf, we see a difference. We see that the conditioned plant, we can see that the seeds that have been conditioned for saline conditions expresses a very high or a high peak of reactive oxygen species compared to the other objects. A week after that establishment of that fourth leaf, and we take a reactive oxygen species measurement again, we see that there is a catch-up. We see that the control conditioned seeds and plants basically basically show a similar reactive oxygen species concentration compared to the conditioned seeds, whereas the plants that have been exposed to normal growing conditions show a high average biomass. A normal control treated seed, we increase in reactive oxygen species, whereas the other objects show a less increase in reactive near infrared reflectance of the plants, which we can correlate with chlorophyll activity. and it does a lot more. So it generates a very long list of data, and through our analysis of a formula which correlates to plant health. If we then look at green leaf index of that specific group, again with a normal plant, but if we see a green leaf index which is bigger than 0.3%, then we are dealing with a plant that is experiencing salt stress. So through that combination of extensive data, we can make that gives us all in all a very powerful tool to develop a seed treatment to mitigate abiotic stress, because we now have a tool to measure in a degree.
Agriculture, there's a whole like plant extracts and amino acids and organic acids, but also microorganisms. And because microorganisms are the most complicated one, since they are alive, that's the one that I want to. Thank you, Barry. So microorganisms can do tremendous things for plants in terms of helping them grow. So one of them is an effect on soil pathogens and can help protect the plant against those. There's also microbes that have an impact on insect development. As you can see on the picture, that caterpillar is fully overgrown with fungi. And there's also microorganisms that have an effect on your biomass. So on the bottom picture, that is a result of mycorrhiza fungi that have a positive effect. Important to know is who does what. So there is, so to be precise, one of these is a plant pathogen. You know exactly what you have because you don't want to have an effect in your plant that you were not expecting. It's not within all microbe families that there is human pathogens and plant beneficials in the same family, but it's also important if you want to have a biostimulant. A thing for is early colonization of the root system. Why do we want that? When the root starts to develop their materials, it matters what amount of space you have to apply them. You can go to the next slide, Barry. Thank you. And the picture, please. Mycorrhiza fungi are very, ranging from 50 to even up to 500 micrometers. You can imagine that if you want to apply that with a 2 micrometer thick film coat layer, that is complicated. And capture this photo. So this is onion seed that we film coated with mycorrhiza, and it shouldn't be possible to capture a 250 micron spore in a 2 micrometer. Imagine, or if you know the process of treating seeds and all the rubbing that the seeds do along each other, then that spore will never stay adhered to a seed properly. So microbes and your seed treatment, there's a lot of things that you should consider. So that is not just your film coat and your pallet and the components that you use in that, but also plant protection products, other actives, also other beneficial microbes play a role. Seed has an impact. So there's a lot of things you need to test and be sure that they work before you can bring a microorganism into a commercial seed treatment application. So as an example, to show you how delicate microorganisms are to work with, if you test 3 different film coatings with one specific trichoderma strain. Can you bring up the graph? Thank you. Yeah, so 3 different coatings, 1 trichoderma strain. We've tested for compatibility for 24 hours. Why did we do that? Because in large treatment facilities, they blend the film coat, the plant protection products, the nutrients, whatever they bring onto the seed in a big tank, and they use that throughout the day. And sometimes they use the leftovers the next morning. So we decided to test for 24 hours. In this case, it is just the film coat and the trichoderma strain. You see film coat A is more or less stable for 24 hours. Film coat B, we lose quite a lot after 24 hours. And film coat C, we decrease the trichoderma below detection limit. So after 24 hours, we didn't even find it anymore. If we then take film coat A, which we think is compatible with trichoderma, and we mix that with a couple of other trichoderma products, you get something like this. So number 1 is A from the previous slide, and that's compatible. But you see that trichoderma 2 and 3 are struggling. So it's the same film coat. You could say it's more or less the same microbe because it comes from the same family, but it is not that easy, unfortunately. Different trichoderma species have different preferences. Sometimes the way, so there's a lot of things to consider when you look at the broadest sense of the word. So a lot of microorganisms are still combined with chemical plant protection products, which makes sense in a way that everyone is still getting used to having biologicals. The effect is still to be discovered. So having both is kind of an insurance policy, but it could be tricky to combine a beneficial fungi with a chemical fungicide. Because that chemical fungicide is made to kill that fungus. So what you see on this picture is a combination of let's call it dots. So there's 8, more or less 8 big, so nothing growing in those areas. And that indicates that one or both of these microbes are excreting compounds that are preventing them from growing more towards each other. That tells us that these 2 are not on a friendly basis, and they are interfering with each other's growth. Depending on the challenges that you're trying to resolve in terms of compatibility, you could, 1 click more, Pari, please. You could apply products in separate layers, depending on what their role. Have different layers with different products. For instance, you have a couple of different products that play a role in different areas. So one is there to protect the soil, but they are not valid, and because they have a different area that they are going to play when the seed is in the soil, they thing, but you can still apply them in the same seed treatment. We're missing a slide, but that's fine. I can talk on that one anyway, because I think it's important. It's important to know if your plant and your microbe are compatible. So That's especially the case when you work with rhizobium. Rhizobium is only compatible with legume plants, and then it's very, very strain specific. So if you have a soybean, you need a bradyrhizobium. If you have a chickpea, you need a mesorhizobium. It's important to be aware of what seed you have, which microbe you need to get the utmost out of your combination of products. So it's not a matter of having a product that works and wanting to roll that out on 10 different crops. You need to be absolutely sure that what you're doing makes sense. And then, of course, the most important thing in the end is that your microbe can release from your seed coating. So you see here film-coated seeds on the left and in the middle, and on the right side there are pellets. The plants don't look so good, but that's because we are growing. But you won't see an effect because the microbe cannot move on its own. We've seen that in some of our research, that we were struggling to understand why with different pellet types we would get a different effect of the microbe. But that all has to do with the fact if your microbe is able to migrate from its position independently or major limiting role. And the last slide. The main message of our presentation is that with biologicals, it's important to have microclimates, different mechanisms, different effects. You need to know what's your challenge for which crop and find a solution for that. Because different crops might need different assistance, but also different fields might need a different solution. So we're in favor of having a specific solution for the problems to have the most optimal growth in the end. We'll take any question.
Thank you very much, Carola. So we'll have both of you back, Barry and Carola. Thank you very much for that very nice presentation. I liked it when Barry put it in capital letters, microplastic free. Right. So, and I think that actually jives quite well with one of the questions asked in the previous session. Right? Is it okay to use microplastic, etc.? And I think, Barry, the message from your talk was very much on how ROS determination can be a very valuable, actually help to provide solution in developing seed treatments. So thank you very much for that message. And this was followed by Carola with the biologicals. I think her message was pretty much how delicate it is to work with microbes, right? And she ended with one crop, one challenge, one solution. So let us see, with all those information that you all provided today, is there a string of questions for you all? Okay, one question, I think this appeared earlier in the previous presentation, but I agree these two speakers are whom this question should be addressed to. If we coat the seeds with microorganisms, what will be the shelf life of the microorganism, and how far these seeds can be stored for commercial, from the commercial standpoint? Yeah, Carola, I think it's more yours.
Thank you. That's a good question. From a commercial point of view, we try to match the shelf life of the seed. So if we look at vegetables, and we take lettuce, for instance, those seeds are primed. The primed seeds have a shelf life of 12 months. then it's important for us that the biological is stable and viable on the seed for 12 months, because that's the window that the seeds are sown in. And then there is, of course, what is the effect of your microbe in the soil and how long can that effect last? I think that depends a little bit on your microbe. If you look at Rhizobium, for instance, they make nodules in your root system. And as long as those microbes are happy and growing, they are fine in these nodules and they continue to take up nitrogen. Other microbes might struggle a bit more depending on which soil you put them in, what life already is present there. And that's why we advocate for on-seed application, because if you have that early establishment, you have a greater chance for these microbes to have a long-lasting effect. If you choose to apply microbes through foliar application, which sometimes you need to do because that's the application and you're targeting insects, or you're targeting leaf fungus. But if you're targeting biostimulants in foliar application, you're gonna lose the battle because everything is established already and your microbe that you're applying is not able to find its way to where it needs to be, and it cannot win that battle. So depending on what you're aiming for, early establishment is your best chance for long-term effects.
Okay, thank you for that answer. Also, is there any treatment which could increase the shelf life of the seeds if they are stored for longer period, example, more than 1 year up to 2 years?
Can I maybe answer that, Carola? Or yeah. Well, in general, or to be completely clear, I interpreted this question as in just harvested seeds. So I guess it's a completely other story if we're talking about seeds treated with biologicals, for instance. But just normal seeds, it's just a, if you're talking about orthodox seeds, just make sure that you dry your seeds well and store them under oxygen poor conditions. That will increase your shelf life of your seeds significantly. And that's there are all other treatments. Stay away from wet treatments, keep them dry and keep them deprived of oxygen. Not completely, because then they will suffocate, but the less oxygen, the better, and store them under low relative humidities. So are
Pesticides or fungicide or insecticide, or are they complementary?
I think we need to go for complementary. A lot of the chemicals have a very broad spectrum in which they work, which is, that spectrum is a lot less broad when you look at biologicals. So you either need to combine 5, 6 different microbes that then all need to establish happily in every condition, every soil type, every, so that's the complexity. If we use them together, we can still lower our chemical input. We can do good by the soil, we can do good by the plants, but then that's probably our best chance to keep up the production of food that we need.
Okay, now biodegradable materials may break down into microplastic with, especially when degradation is incomplete. Are compostable materials a better and greener choice?
It's a very interesting question. Well, let's start off with compostable materials. So in my opinion, it's a little bit semantics. Compostable and biodegradable, in my opinion, are literally the same. although the rules and regulations states microplastics free, microplastics are well defined in that legislative, in those laws within Europe. That's our prime focus. However, within our development within IncoTech, we also take biodegradability much into account, and we try to limit it as much as possible. Because as your question also suggests, microplastics free needs to be biodegradable. Those are two different things. I completely agree. The latter one, it needs to be biodegradable. Yeah, it needs to. But keep in mind that as soon as you look at biodegradable, you're also looking at materials that are basically active food sources for soil-borne pathogens, for instance, and that those can basically enhance disease troubles, etc. So there's a fine line you need to walk there. So yeah, that's where expertise comes in.
Thank you. Very clear. One more question. Do you have some data on how long will certain biological microorganisms, example trichoderma, incorporated in seed coating will still be viable? Shelf life, basically.
Yeah, like I said, if we look at vegetables and pellets, we aim to match the shelf life of the seed. We have done trichoderma in a pellet, and we can have 1 year. But we've also, for fun, plated that pellet 2 years after we coated it, and we could still find viable trichoderma. But I think the most important thing is it starts with how good your initial product is. A rhizobium that has a shelf life of 2 days, which the seller tells you to apply that on seed right before you start sowing, we cannot make that into 3 months on seed with seed treatment technology. So the better and more robust your microbe is to start with, the easier it is to incorporate that into commercial seed treatment. But for gram-positive bacteria that make spores and for fungi, you can get at least 1 year and sometimes longer, depending on the microbe.
Okay, there are more questions coming in. Live microbes are sensitive to temperature, humidity, and UV light. This might be challenging in large-scale operations where seeds travel across regions. Have you thought of these challenges during your experiments?
I think the answer to that is yes and no. So we cannot include every condition that these seeds will encounter. So for our experiments, it's important that we have that we use conditions that we can repeat easily, so that our trials are consistent. But we also look at, okay, what are some of the more extremes? What do we need to consider? We have done seed treatments that had to go to Spain. Okay, what type of microbe do we have? Do we send those seeds out under normal conditions, or do we do that under a cool and under a transport that is at 10 degrees or at 5 degrees? You know, these things we consider. And yeah, so transport often is only a few days. And a lot of the seed companies store their seeds under strict conditions. So what we do is we make sure that we look at that, but it doesn't need to be under extreme conditions for 6 months or so.
Okay, this one I think will be a short answer. Is this treatment effective against seed-borne diseases or capable of reducing their incidence?
Can I get this one?
Yes.
If you want a solution for seed-borne diseases,